Hello, everyone. My name is Vinod Venkatraman. I am the VP of Technology at Great Learning, and it's a pleasure to have you all here as we, today do our masterclass in first steps in machine learning. So before we go deeper, into the topic of machine learning and take our first steps, I want to spend some time explaining who is this talk for. So this talk, is primarily for people who are interested to get started with machine learning, right? So if you have heard about machine learning and you wonder how it works, then this is the right talk for you. Also, in the world of technology, what happens commonly is when new things come out, a lot of documentation, lot of tutorials, lot of the material around the new technology has a lot of jargons and buzzwords, which essentially makes it difficult for people to get started. So if you have faced that problem in machine learning, again, you are in the right place. So today we will, essentially in the next 1 to 1.5 hours, we will do a plain English trailer of the machine learning world, right? So this is not an advanced, masterclass. We're not going to go into too much depth and cover all the areas. Instead, we're going to understand and what machine learning is and take our first steps in it, right? So that is the audience for which this talk is for. So moving on, what is the I wanted to discuss what is the agenda of this talk, right? So what will we learn? So we will primarily start with understanding what machine learning is, and again in plain English, because we don't want to do another jargon and buzzword filled talk. So I wanted to keep this as simple and plain English as possible. So we will in plain English understand what machine learning is. Then why do we need machine learning in today's day and age? What is the need for this new thing, and it has become so popular? Why has it become so popular? Is because of the need we have. So we'll understand why do we need machine learning. Then we will go on and see a few software, and websites and apps and services which are already using machine learning, where you and I as consumers are witnessing machine learning and how it is elevating the user experience, right? So we'll then go and look where are we already witnessing machine learning in action, and we are all experiencing it, whether we know it or not. So after we cover these basic topics, we'll actually get to the core of this talk, where we will discuss how can a machine learn, right? So if you have any programming background or any tech background, you'll know that machine learning is something like magic, right? And we will try to unravel that and try to figure out how can a machine learn. Moving forward, we will look at different types of machine learning algorithms that exist, right? This will help us create a framework in our heads, right? So that we can when we look at a problem, we can see, okay, we can use this machine learning algorithm to solve it. We can use that machine learning algorithm to try and solve it, right? So we look at the types or the classification of the machine learning algorithms at a broad level. After that, we get to a hands-on part. This is where we will actually be writing code in Python, and we will be solving a couple of real-life problems using machine learning. So one such problem is to predict the weight of people based on their height. We will use a data set which has weight and height, and we will see how we can make our machine learn and predict the weight of people given their height. So that's the first problem. The next problem we'll do is we will try to create machine learning. We will try to create write some code in Python which will help us shortlist resumes using machine learning, right? So if we know a candidate's degree, if we know what percentile he got, what percentage he got, and we know whether how much work experience he has based on all these fields, and we will try to write a program which in Python which will help us shortlist resumes, right? And after that, to conclude this talk, we will see what next, where you can go to learn more machine learning, right? How can you continue your journey after having taken these first steps? All right, so that is the agenda of this talk, and I hope it excites you. Again, it is going to be in plain English, not much jargons, and we are going to actually do some hands-on stuff. So hang around. Okay, so moving on to the first item in our agenda, which is to understand what is machine learning. So the definition of machine learning is when a machine learns without being explicitly programmed to do so. Now, what does that mean? Let's take a moment and try to understand the statement. So typically, if you have been involved in writing software, or if you have been involved in defining what a software should do, what happens is the person defining the software, the product manager, normally comes up with the requirements. This is what you have to build. For example, in the case of shortlisting resumes, the product manager will come up with, you should have a job description. Job description will have, the degree of the candidate, will have his work experience, will have his, what percentage he got in his degree, right? Is he a referral or not? All these details will be captured in the job description. And then the product manager will tell the engineer that you have to shortlist this resume if it matches these criteria from the JD, right? So essentially, we are explicitly in a way dictating how to shortlist a resume. And then the programmer or the engineer will actually go ahead and implement this logic in his favorite programming language. Excuse me. So the engineer will go ahead and implement this logic in his favorite programming language. And then when resumes come in, the code that is given to the machine will basically look at, is the number of years of experience of the candidate greater than the expected years of experience in the JD? Is his percentage greater than the percentage of minimum percentage required in the degree as per the JD, right? So essentially, the machine is being explicitly told how to shortlist a resume. So traditionally, that is how software have been built, right? So that is what is explicitly programmed. So that is when the machine is explicitly programmed. Now, machine learning we are defining as when a machine learns without being explicitly programmed. What does that mean? What that essentially means is the developer or the engineer has not written all this logic. Instead, the developer or the engineer is pointing the machine to data. So historically, these are the resumes that came in. For each resume, this is the years of experience he had. This is the degree that the candidate had. This is the percentage of marks that the candidate scored, and this is the final result. Yes or no? Did we shortlist him? Yes or no? So we'll have a series of such records, right? And then the engineer will not explicitly programmed to shortlist resumes. Instead, he will say, take this data and see on which parameters do we actually shortlist people, right? Historically, we have rejected 100 people, 100 resumes, and we have accepted 25 resumes. So the engineer will point the machine to this data and say, learn from this data using this technique, and then be ready to shortlist resumes. So there, the programmer is not explicitly programming saying years of experience should be greater than the JD's years of experience, or marks or percentage should be greater than 80 or 70, right? So essentially, this is how you write programs in machine learning. You don't explicitly program the business logic into the code. Instead, the engineer or the developer will point the machine to the data, ask it to learn from that data using a machine learning technique, and then the machine has itself figured out what are the qualities you look for in a resume when you shortlist it, right? And then it will shortlist, right? So that is one example, right? Where traditionally we would have explicitly programmed the business logic, whereas with machine learning, the machine is learning those attributes, those, what goes on in the head of the person who's shortlisting. The machine is looking at the results and seeing, okay, can I reverse engineer, right? Can I reverse engineer the logic, right? And then use it to shortlist resumes. Now, another example. Let's take an example where the machine is given the task of recognizing handwritten digits. So you can see a couple of handwritten digits here, right? 1 and 8. So again, traditionally, what will happen is the engineer will go ahead and write, okay, a 1 looks like this, meaning it will have a vertical line at the center of the image. At the end of the vertical line, there'll be a horizontal line, which will be of nearly equal length on the left and right. And at the top of the vertical line, there will be a line with a 45-degree angle towards the left, right? So this is what is again explicitly programming, but machine learning is not explicitly programming, right? It is when the machine is given a lot of ones, and it is looking at, okay, this is what you told is a 1. This you told me is not a 1. So look at all the ones that you gave written by various people and figure these things out. Okay, there'll be a vertical line, there'll be a horizontal line, there will be this 45-degree line. And if you think of it, the number of ways in which people write 1, some people write 1 just as a vertical line, right? Some people write 1 differently. So there are many ways of writing 1s. So in a way, explicitly programming for each of those use cases is a waste of time, right? Because new people will come and try to write it slightly differently. So the only real way for a machine to actually recognize handwritten digits, only scalable way, is when it is looking at what you have already classified as 1s, right? The digit 1s, and see how various people write it and try to learn from it, that how is a 1 normally written. And once it has learned that, right? So again, there the programmer is pointing the machine to that data. He's saying, okay, take these 10,000 images where different people have written 1, right? And look at how they have written and try to learn, right? How a 1 looks like, how human beings write 1s. And then when more digits people write, I will pass them to you and you tell me whether which of those are 1s and which of those are not 1s, right? So here again, we are not explicitly programming because it's very difficult to explicitly program all the ways in which human beings will write 1s. Whereas if you have that data and you have spent some time classifying it manually, then you can feed all the data into the machine and the machine can, learn from it and try to figure out how people write 1s. Okay. So what have we learned? What we have learned, machine learning is when the machine learns without being explicitly programmed to do so. So traditionally, software has been built by explicit programming. The machine only does what the engineer actually programs it to do. If he programs the machine to act as a calculator, it'll act as a calculator. If he programs the machine to act like a game, it'll act like a game. Whereas here, without explicitly programming, we are actually telling the machine that, okay, this is how this is historically, this is the data I have historically, right? And I have the classification already in place that these are 1s, these are not 1s. Go learn from it. And when I give you more digits, tell me which of those are 1s and which of those are not 1s. Okay. So I hope that gives you a high level understanding of what machine learning is. So moving on. The next thing that we wanted to discuss is, why do we need machine learning, right? Why is this becoming such a hot thing, such a popular thing, and why do we need it? Basically, in today's day and age, we need systems which can continuously learn and adapt and improve. So what do I mean by that? Right. So if we have a machine learning based system enabled, when people start writing 1s in new ways, the machine can learn automatically as soon as you point them to, okay, these are the new ways in which people are writing 1s. Imagine that with actually the traditional way, where the developer will now have to take up a task to handle this new way of writing 1, right? That is just a waste of time, and it just slows down your business. So essentially, given the volume of data getting generated, it is very difficult to actually, handcraft and code all the business logic into programs. It is better to allow the machine to learn from data, right? And continuously keep learning. So once you set this up, right, all you need to do is provide power to the machine and keep pointing it to new data. Then the machine can keep learning, okay, this is the new way in which people are writing 1s. These are new ways, in which people are writing 8s, and so on and so forth, based on the business problem that you're solving. And the machine can continuously learn, because once you set it up, you just have to keep pointing it to new data, and it can start, learning from that as well. And in today's day and age, where so much data is getting generated, the only real scalable way to build a software that is on top of its business problem is for the machine to actually continuously learn, right? So machine learning, we need, because we want to build systems which can continuously learn, adapt, and improve. And that is very easy to do with machine learning, because there you're not coding all the logic in. You are just pointing the machine to data, to facts, to truths, right? Pre-classified, and the machine is ready. It's learning, continuous learning, right? And we already covered. The next point is to handle explosion of data, right? So there is so much data coming in, right? So no human being can sit and figure this out. It is very difficult. If you had to, let's say, and let's take an example, right? So many photos are getting uploaded to Facebook. If Facebook used human beings to tag photos in which you are there or your friends are there, that will just be impossible in today's day and age. They would probably sorry. So if Facebook wanted to do tagging, then it will be very difficult for them, because there are so many images coming in, like a million probably images coming a second, and how does a human being ever catch up? Cannot catch up, right? So to handle the explosion of data, machines have to start looking at, be able to look at this data, in this case which is images, and tag people in it. It has to do it automatically. So that's the other reason we need machine learning, is basically to just handle the amount of data that is getting generated. Next is to reduce mundane work for human beings. Now just imagine that job, day in, day out, you sit and you keep tagging faces on photographs. That is just a waste of the human race, right? Why do we want to do that? Why would anyone find that as a lucrative career option? No, it's just boring, mundane work, right? We want machines to do all the mundane work. We want to do creative work. We want to create new machine learning algorithms. We want to, try different machine learning algorithms and see which of them is giving a good result. So machine learning, once you enable a machine learning enabled system, right? Once you have that, it will reduce the mundane work for us, right? And coming to the last point, it is to reduce errors and improve efficiency. So all said and done, human beings in general are more creative than machines, right? Human beings have this creative angle in their brain. A part of their brain is about creativity, the other is about solving and thinking and calculation and all of that. So we have that angle in it. But if you keep asking a human being to do a mundane job again and again, there is a chance that they will make an error. It is just, errors are bound to happen. But if a machine wants to teach it, it's pretty sure. So if you have a piece of code that is bug free, it will keep doing the same thing again and again and again, a million, a trillion times without any errors, right? So what it does is, with these, with this much data exploding, and if a machine learning enabled system is there, it will, reduce errors, even in tagging, face tagging, right? And it will improve the efficiency because it is continuously learning. So first time, maybe in some photos, it does not recognize me from a side angle, but once that is told to it, the human being just tells, okay, this is also the same guy. It's just a side angle. Then the machine next time will now keep and will be able to tag all photographs from the side angle, because it has now learned how I look from the side angle, right? So why do we need machine learning? It is to build systems which can continuously learn, adapt, and improve. It is to reduce mundane work for us human beings so that we can do more creative, more innovative work. It is also to handle the explosion of data. There's so much data, human beings just cannot, catch up tagging those, or doing whatever with the data we want to do. And finally, to reduce errors. Okay. So those I think are the primary reasons why we need machine learning. So moving on, now we will next going to look at some software, some apps, some websites, some services which are using machine learning to actually improve the user experience. In fact, machine learning is the core differentiating factor in all these products. So let's start with Google Assistant. So this is something, if you have an Android phone with the latest version of Android, in your pocket there is a machine learning enabled system sitting, right? So it's the Google Assistant. What is it doing? It is first, learning how you speak. That's the first thing, because its interface is a voice interface, so it has to learn how you speak. The next thing it is learning, it's continuously learning. It is even trying to learn what are your appointments. It is trying to learn, what is the times and when you go out and play. It is continuously learning based on all the signals it is getting from the device and all the data that you are exposing to it. And it is trying to act as a virtual assistant. So in today's day and age, we don't want every human being to have a human assistant. Instead, Google is trying to solve it with a virtual assistant, with a Google Assistant sitting right in your phones. So Google Assistant is using machine learning to actually learn about you, right? What do you like? What do you dislike? What are the news articles that you normally read, right? What time of the day do you wake up? What time you go to sleep? What time you are busy working, right? If you see Google phones, when you wake up and you're ready to go to office, it shows you office will take 20 minutes to reach. It shows you, right? and which is 10 minutes more than yesterday. So how is it doing it? Because it knows at this time you travel. So it's learning, right? The machine is learning that this is the time, these are the weekdays, and he travels during this time. So yeah, so it's making an educated guess. You're going to office. But then when you reach the office, it actually has your coordinates. So from there, it's figuring out, oh, this is actually, he works in this company because he goes there every day, right? So machines, Google Assistant in this case is actually learning from data, that, all the signals, all the, things the mobile phone is giving it, as well as all the data you are choosing to expose to it. So the next software I want to bring up is Google Maps. So how is Google Maps using machine learning, right? So Google Maps essentially is a way to help you get from place A to B, right? So where is it using machine learning? So it is using machine learning to figure out what is the shortest path right now to go from place A to B in terms of time. So it optimizes for time. But then it also has to, take into account things like traffic. So it has to continuously learn, okay, now there is a traffic jam on Outer Ring Road in Bangalore. So if it takes that route, it has to suggest an alternative route, right? So Google Maps is essentially learning the business problem it's trying to solve is to help people get from place A to B, right? And to do that, it is learning from various things. It is looking at satellite images, looking at traffic. It is looking at, what routes normally other people take when they want to go from A to B, right? And it is continuously improving. Maybe first time it will suggest you a road that's not very good, but then as it gets more and more data as to how people, work around that road, or what is the divergence they take to avoid that road, it will start suggesting you the same. So again, there the system or the service is learning from data, and it is, using machine learning to learn and to suggest new improved, routes from place A to B. The next thing is, Netflix. So Netflix has come to India now. I guess it's been a year. Netflix is here, right? So Netflix is, about entertainment. It's about, and most of it is done on the mobile phone. So most people access Netflix on their mobile phones. So when you open Netflix, it only excuse me. So when you open Netflix on your mobile phone, it only has so much real estate. It only has this much screen space, and it has to show you, you know, relevant things. So there, the machine, what is the problem that Netflix is facing? I have only this much real estate, and I have to show the user things that he would like to see. So recommendation. So Netflix has a recommendation system which learns not only from what movies you have watched, but also from what movies other people like you have watched, right? What are movies that it should showcase on the homepage when you launch Netflix, so that there is a higher likelihood of you engaging with that content. And once you engage with the content that it is recommending, you're most likely to renew your subscription whenever it comes, the end of the month. So there, machine learning is like critical. Without machine learning, imagine there has to be a workforce in Netflix which for each user is trying to tag, okay, show him this. Okay, when that user comes, show him that. That is just, so error prone, so inoptimal, right? It is all up to human beings' judgment, right? What should I show? But if a machine can learn and recommend, then we can be certain that we are providing similar experience to all our users and at some quality. And for Netflix, that's critical. So if people open Netflix to watch something, or they're just getting bored, they open Netflix and nothing that comes on the screen is appealing, then they'll just close Netflix and go to some competition, maybe Amazon Prime, not sure. But yeah, so for them, machine learning is like critical. Next, online advertising. So again, online advertising, the domain, machine learning has made a lot of help the domain a lot. So here, based on the user and his what he's right now looking for, right? So sometimes these creepy things happen, right? You're looking to buy a Nike shoes, and wherever you go, you start seeing these Nike shoe ads. So we wonder how did the machine know? So the machine has learned from data. Maybe you did a Google search for Nike shoes, right? Maybe you even visited a Nike store. Who knows? So the point is there, the machine is learning from your past activity and is trying to understand what is the thing right now that you're looking to purchase. And then it is trying to use that to show you more relevant, more meaningful ads. So that's how online advertising and machine learning are being used. So moving on, credit card fraud. right? So one of the risks with having credit cards is that it is easy to swipe and use, right? If you lose your credit card, it's easy for anyone to go to a store, swipe it, and use it. In India, you have a PIN-based system, but in many countries, there is no need for a PIN as well. You just swipe the card and you can purchase. So what if you lose your card? So there, the banking systems, the challenge they are trying to solve is, can I create a pattern of how and where and when this user purchases normally? And what is the amounts that he purchases normally? And whenever there are deviations from it, should I introduce further authentication mechanisms, right? To prevent these kind of frauds to happen. So there the systems are learning from your past behavior, credit behavior or spending behavior. Where do you spend? What type of things, what type of merchants do you engage with? What kind of products do you normally buy? And what is the amount range that you buy? And if things are off, suddenly if a 1 lakh swipe happens on your credit card, it can tag it and enable further authentication mechanisms, maybe send an OTP which is needed or whatever, right? But the aim is that's a critical thing. So without machine learning, again, a human being cannot sit and do this for all the users of the credit card, right? So medical diagnosis, right? Similar. So there we have image data, we have scans, all these scans that are happening, which are all digital images, right? And once you have these images, the machine can learn that, okay, if you have to detect a tumor, if you can show me 10,000 images of the brain with a tumor or 1 lakh images from history of brains with tumors, I can learn from them, right? And then when a new scan comes in, I can make a prediction whether there is a likelihood of this patient unfortunately having a tumor, right? So there also it reduces error. It is more objective because the machine has learned from true data, and it can help the doctor not make a mistake. So very critical machine learning again is being used there, right? So there are more examples: speech recognition, self-driving cars. So self-driving cars have this problem: they have to interpret the world in front of them. When a car is driving, normally the driver is interpreting the world, and the machine, the car itself, is just providing different controls: accelerate, brake, steer, indicators, lights, wipers. These are all the things the car provides. But a self-drive, imagine you remove the driver. Now, what is the problem that machine is trying to solve? It is trying to interpret the world in front of it, like a driver would be interpreting. So there it has to look for stop signs. It has to look for human beings who are trying to cross in front of you. It has to look for speed breakers. It has to detect it has started raining, so I have to start my wipers. Maybe there is fog, so I need to switch on my defogger, right? So there are like so many things. If you just think of it, that is a really complicated problem. Self-driving cars, and it is happening. All these things are happening. Self-driving cars are still work in progress, but in many countries, they are already on the streets. And maybe in whatever 10-15 years, they might be on the streets in India as well. Who knows? So that will be fun to see them drive in India, though. Okay, so we are witnessing machine learning. So basic takeaway from this slide: it is happening. It's happening all across. It's happening on your phones. It's happening on your laptops. It's happening everywhere. And machine learning is actually the core differentiating factor for many products today. If you have a standard product which will just do what it is supposed to do, what the programmer programmed it to do, it can only do so much. But if you have a machine learning enabled software or a service, then you have the levers to actually wow your users, right? So Google Maps wows me whenever I use it. Netflix wows me whenever I launch it. It knows exactly what next I should see, and I just blindly go by its recommendations, right? Right. So maybe doctors can vouch for how in medical diagnosis, all this image thing, the scan thing that is happening, how good accuracy it's giving. So essentially, it is happening across all domains. And if you learn the skill of how to be able to create systems which are machine learning enabled, then you will be creating products which have the potential to wow its users, right? They'll go, wow, that's good, right? So we are witnessing it all over, and it is now for all of us to learn this and enable this in our own softwares. Okay, moving on. Now we come to the core of this topic, which has been so this is something I have learned in the last 2.5 years. It's not that I've done my master's or PhD in this. So when I started looking at machine learning, some of the things, the main question that came to my mind is, how can a machine learn? Normally machines just run code, right? Whatever code you give it to them, they run it. and they also have a hardware angle. So, maybe the machine can move from here to there and do dry cleaning, or sorry, can do cleaning your floor. But how can a machine actually learn? How do they get intelligence in them, right? So to answer this question of how machines can learn, we will answer the following questions and then see if we can, kind of relate how a machine can learn. First thing we'll answer is, what are machines good at, right? So it is not like these machine learning, machines have some inherent different capability that older machines didn't have. It is not that. So they have similar capabilities. Maybe they have more, in terms of more capability, but it is like similar. So we'll answer the question, what are machines good at, right? Then we will try to answer, what are the kinds of things we want the machine to learn? So what are machines good at is the capability of machines. What are the things we want the machine to learn? What are the things, we want them to learn? What is it that we want them to learn? And then we will see, given that they are good at this and we want them to learn this, how can a machine learn that? What can a machine learn from? That will be the third question we can answer, right? And the fourth question is, how can a machine learn from those things, right? So what are machines good at? What do we want them to learn? How can they learn that, right? Are the questions we'll answer. And then we will see if we have answered the question, how a machine can learn. Okay, so the first question was, what are machines good at? So machines are extremely good with numbers, right? So take a second, all of you, right? And try to calculate the square root of 1349. Square root of 1349. So normally, a human being would take anywhere between 20 to 50 seconds to answer this to any reasonable precision. Whereas a machine will do this in a microsecond, right? So they're good with numbers. They are the biggest number geek around you. Machines are really good with numbers, right? And machines are extremely fast at mathematical computation. So a mathematical computation like this, a machine will do like in a microsecond. So they're extremely fast in mathematical computations. So they're good with numbers. They're extremely fast in mathematical computations, right? And all machines have some form of memory in them. So they can remember what was the output of that computation that I did, right? Or maybe they have persistent memory, also like a disk, where they can remember even across restarts, even across the times when they are restarted, they can remember, okay, when I last did this, this was the output. Right? So the core strength of machines is they're good with numbers, they're extremely fast in mathematical computations, and they're capable of remembering the past, whatever they did in the past or whatever you told them in the past. So these are the key, things that machines are good at: numbers, mathematical computation, and remembering, right? Remembering what you told it or remembering what it computed. So that is the core strength. So that answers our first question. Now we are going to take the second questions, is what can a machine learn from, right? So a machine can learn, yeah. So second question, what can a machine learn from? So machine can learn from data, right? So because as I said, the way a machine can learn how a 1 is written is you actually pointing it to all the ways in which 1 is written by human beings. So the programmer or the engineer or the human involved in helping the machine learn is telling the machine to learn from data. But what do we mean by data? So data is basically either past events, which are facts because it has happened, it's a fact, and what was the outcome. For example, was this image a 1? Was this resume shortlisted? That is the outcome. And what is the past event? What are the facts? All that, how is the 1 written? And whether it is classified as 1. So machines can learn from data represented as facts, right? And past events and their outcomes. Right? Now, most of this, given the strength of machines is to interpret numbers, most of these facts have to be represented as numbers. Remember, they're awesome with numbers. So once you represent these facts as numbers and give it to them, they can crunch those numbers and figure out, oh, when this happens, when the number is like this, in this range, then this happens, then that happens, so on and so forth. Right? So what can a machine learn from? It can learn from data, right? Past events and their outcomes. More specifically, the data represented as past events and their outcomes. And all of that represented represented as numbers because they're awesome with numbers. Okay. Now we will answer the third questions. What do we want the machine to learn? Why do we want the machine to learn at all, right? So we want the machine to learn from past outcomes to predict future outcomes. It is so awesome, right? These weather services can tell you, it's going to rain today, so take your umbrella out. It's so awesome. How did they know, right? So obviously they're looking at some data around, clouds and wind and all of that, but they're also looking at trends, right? They're also looking at, learning from data, past data, to predict whether it will rain today, right? We also, want the machines to learn from its mistakes to make better predictions in the future. So obviously no one is perfect, and neither will the machine be to begin with, right? So a machine will, since it's learning primarily from data, the learning that it has is dependent on the quality of data you give it. If you give it all the data of ones which are like drawn very similarly, whenever a new one comes, it might struggle. A new type of one comes, it might struggle, right? So, but once you tell it, okay, this was also a one, then it has learned, right? It has learned that, okay, ones also look like this. The digit one, when written by humans, also looks like this, right? So we want machines to learn from past outcomes to predict future outcomes. We want machines to learn from its mistakes to make better predictions in the future, right? So these are two things where there is a machine is learning from data and making predictions. The other thing that a machine can learn is to look at data, right, and detect patterns inside it and insights, right? So that is the other kind of learning we want to have. Let's say there is no historical data, there is just one data set. There is just a data set of, let us say, uh, all the locations where there is a likelihood. Basically, it's like an image of a satellite image of, let us say, HSR layout, and it has to basically look at that data and figure out patterns as to where there are traffic jams. So there is no past, no present. There is just one image, or there are a set of images. That's it, right? So these are the two major kinds of learnings we want the machine to have: to learn from data that has happened in the past and to predict future outcomes, right? And the next is to look at a data set in itself and to detect patterns in it, right? So these are the things that we want a machine to learn, right? So we have answered so far what are machines good at. Then we answered what can a machine learn from, and then we answered what do we want a machine to learn. Now let's answer how can a machine learn from data, right? So we have this historic, let's say we take the historical data represented as a series of input output pairs. So we have a lot of these input output pairs that have historically happened. They're all facts, they have happened. One thing a machine can do, given it is awesome with numbers and mathematics, is to find a mathematical function which can generate the output as close as possible to the actual outputs. So you have these input output pairs. Let's say, let's take the case of the Sensex index, right? So let us say on 1st April Sensex was at 30,000. On 2nd April, so that's an input output pair. 1st April 30,000. 2nd April maybe 30,300, right? So you have this historical data. Now, based on that, given that the machine's core strength is numbers and crunching numbers and mathematical computations, it can come up with a formula, mathematical function, f of x equal to y, right? It can come up with that function where for all the inputs that you have given it, the input output pairs, the output it is generating, that function is generating, is as close as the real output for that input, right? So looking at this graph, this is the input, this is the output, and this is all the data points. The blue are all the data points that you have given it. And what has it done? It has come up with this red line, which is a function, where given an input, it can actually tell you the output. And it has done that. So there are so many possible, right? There could have been a line like this. There could have been a line like this, like this, like this. What it has done is figured out one function. This is the learning that it has had, this red function. And it says, given the data you've given me, one type in which I can learn is to actually find a mathematical function which will generate the output as close as possible to the actual outputs. Okay, great. So now you know this function. So now what? Now you give me any input. I can use that function. I can pass it to that function and give you the output. So even if there is a missing value here, I can actually tell you what it would have been. Or even in the future, I can tell you for new values what the output can be, right? So one way in which a machine can learn is to find a mathematical function with which it can take inputs, to which it can give inputs, and whatever output that function gives is the prediction that the machine is making, right? So in this case, it has looked at all these blue points and it has learned this red function, right? And in this case, it has looked at all these blue points and it has come up with a straight line. This is the y equal to mx plus c. This is the learning that it has had. So such form of machine learning where the machine comes up with a function, right, with which it can predict values, and it came up with the function looking at all the data you gave, the input output pairs that you gave. So such form of machine learning is called regression analysis. So this is one type of machine learning, a suite of machine learning algorithms, right? So where the machine is regressing and trying and to find a function with which it can predict output. Okay, so one way we saw a machine can learn is to find, look at the data, crunch the data, look at the inputs and the outputs, and then come up with a function f, which will take an input and then give the output. And that is the learning it has had. It has looked at the data, crunched the data, and come up with a function. So such form of learning was called regression analysis. So now another type of learning that the machine can have is it can generate a flowchart, right? Looking at the data. So let's take an example, right? I have a data set which tells when do I go out and play cricket, right? The data set has 4 columns. One is what is the sun like? What is the outlook of the weather? Is it sunny? Is it overcast? Or is it raining? So on that day, it was whether it was sunny, overcast, and raining. Then the next thing maybe I look at in the data set that is there is what was the humidity that day? Was the humidity high or was it normal? And the third, so to speak, feature or property in the data set is how strong was the wind? Was it a strong wind or a weak wind? And given the values for each of this, the outlook, the humidity, the wind that day, there is a factor telling whether I went out to play, yes or no. So if I have a series of such data and I feed the machine that data, it can actually come up with a flow chart saying, looking at the data, it can figure out whenever it is sunny and it is normal humidity, you go out and play. But whenever it is sunny and it is very high humidity, you don't go out and play. You don't want to sweat in the sun, right? Whenever it is overcast, pleasant weather, like it is in Bangalore right now, you'll go out and play. As per the data, you go out and play. But whenever it rains and the wind is also very strong, meaning there is like a tufan happening, right? Or an andhi or whatever, in that case, you don't go out and play. But when it is raining and the wind is weak, maybe you go out and play. This is what the data is telling it. So the machine can look at the values for these parameters, these inputs. So the input here is the outlook, the humidity, and the wind. That is the input. Given these 3 as input and the actual output is whether you actually went out to play or not on different days. So it has this input, these 3 values for each day, and whether you went out to play that day or not. Given all of this, the machine can actually learn this, can come up with this flow chart. And then any day when it is, it can look at, okay, what is the humidity, or what is the outlook today? It's sunny. What is the humidity? Looks like normal. So it can suggest you to go out and play. Hey, you haven't played for 4 days. Why don't you go out and play? This is the normal time in which you go out and play, and the weather seems good for it. That will be a software that will wow you, right? Okay, the software actually cares about me. It actually is telling me to go out and have some fun, right? So machine can actually learn from past data and not only come up with mathematical functions, it can also come up with flowcharts. If you see, this is what a programmer would have done. If you had to code this in the traditional way, you would actually have written these if-else blocks. If outlook is sunny and humidity is normal, suggest the user to go and play, right? So here we have not coded any of that. We have just shown it data. We have just given it data, and then the machine has learned. And in this case, the learning it has had is this flowchart. It has come up with this. So such form of machine learning algorithm where the machine tries to come up with a flow chart based on which it can make decisions, yes, no decisions, is called decision trees, right? So we have looked at regression analysis, we have looked at decision trees. Okay. So now if you remember this slide, let me go back to it. So we want the machine to learn from past outcomes to predict future outcomes. We have done that. We can do that with regression analysis. We can do that with decision trees and many, many more algorithms. The other form of learning we wanted the machine to have is to learn from a given data set, no past, no present, right? And detect patterns and insights in that same data set. This is another type of learning we wanted the machine to have, right? So for that, right, another popular machine learning algorithm is called cluster analysis. We're given all these data points. So X could mean something business-wise, Y could mean something business-wise. You have all these data points. What the machine can do is try to segregate them into clusters. So you can say, take this data and segregate it into 3 clusters, right? In this case, it has segregated these data points as the blue cluster, these data points as the green cluster, and these data points as the red cluster. So the machine, this type of learning where the machine is looking at raw data and creating segments out of it, right, is called cluster analysis. So now what could this data be? Business-wise, this could be your users, and this could be the number of purchases that they have made in the last 1 week, and you want to do some targeted marketing to them. So you want to create segments out of that, right? And then you want to, do maybe some marketing to them. Maybe you want to give them some offers, some promotional offers. It could be any business use case, but given data, the machine can find which are the points which are close to each other. You have asked me to split it into 3 buckets, right? So that's an input this algorithm requires. How many buckets to break this data into? And given that, what it has done is it is trying to put closer things together, people who have similar behavior together. And it's trying to break this whole data set into 3 clusters because you told it to break into 3. If you ask it to break it into 4, who knows? Maybe this will be one cluster, definitely. Right? This would be one cluster. Maybe it will come with 2 clusters here, 1 cluster here and 1 cluster here. Right? If you ask it to break it into 5, it will come up with different clusters. Right? So here the machine is not predicting anything or not having any functional learning. It's not learning some function or some uh, some flowchart. What it's doing is essentially segmenting your users into different clusters so that you can do something meaningful with it. So this type of machine learning where the machine learns from data to create insights or patterns in the data, to identify patterns or derive insights from data. One such learning is cluster analysis, where the machines will take your data and will break it into as many clusters as you said, where all those clusters are supposed to be meaningful. They're actually closer to each other, so they have some correlation, something similar, right? So such learning is called cluster analysis. Okay, so we have looked at regression analysis, where the function is coming up, the machine is coming up with a function. We have looked at decision trees, where the machine is coming up with a flow chart, right, to make a yes/no prediction. And then we have looked at something nothing to do with prediction. It is just looking at data and deriving patterns from it. And one such example of machine learning is cluster analysis. Okay, so now that we know how a machine can learn from data and what types of learning it can have, so it can learn a function, it can learn a flow chart, it can learn about the data and create patterns or segments for your users or whatever that is, right? Now, but how do we know a machine has actually learned, right? You gave it some data, you asked it to do regression analysis, it did that, but how do you know it has learned well or is it learned poorly? So normally, what do we human beings do? We give a test, right? So when we learn something, to see how well we have learned it, we go and give tests, we evaluate ourselves, right? So the same thing, we do the same thing with machines. So what we do is, let us say we have 100 data points, right? We don't give the machine all the 100 data points upfront. We give it a portion of it, maybe 70% of those data points we give the machine. We say, okay, learn from this. Then we test it with the remaining 30%, right? So if it has learned a function, we will now call that function with the remaining 30% of the data points we never showed it, right? And see what is the output that the function is giving versus the actual output, right? And that is how we measure the accuracy of the machine's learning. And we keep doing this with, maybe the 70% you chose are all outliers, right? They're not really, not covering the entire breadth of the data. So in which case the machine will have a poor learning, which will come out when you test it with the 30%. So you then give it a different 70%. You try to randomize, pick a different 30%. Maybe you randomize, maybe you handpick. And this is what, so traditionally you code, you write logic into your program. In machine learning, the developer or the engineer is essentially giving it the right data, right? This is the challenge. The machine cannot itself figure out what is the right data. You have to give it the right data. So you have to give it a representational data. And once you give it that, you can test it with the remaining data that you didn't give it. So normally 70% of the data is given to the machine to learn, 30% is withheld, with which we test the machine's learning. And we keep doing it till we actually get a model, or till we actually get the machine to learn accurately, give good accuracy on the test. So this is called a train test cycle. So we keep doing it, we train it again and again and again, till we have given it good data, good representational data, and then when we test it, we actually see it is giving a good accuracy, right, on the 30%. And once it's doing that, we now have a machine that has learned, which can now be used in production, right? Okay, so we have seen a lot of things so far. So we have understood what machine learning is. We have seen where it is being used, why it is becoming so important in today's day and age. Then we have gone ahead and tried to understand how can a machine learn. It is from data, right? And then we've also seen 3 types of machine learning algorithms, like regression analysis. Then we looked at decision trees. Then we looked at cluster analysis, right? And then we also touched upon how do we know if the machine has learned well, right? So how do we train the machine in a way in which we can actually test its learning? So we have covered that as well. So now the last part before we actually dive into some hands-on stuff is the basic ML terminology. So I want to give you a little bit of terminology, right? Now that we have learned machine learning in plain English, let's put some terminology so that when you speak to others about machine learning, you can speak the common language that machine learning folks talk. So the learning that a machine has is called the machine learning model. It's the model, right? For example, regression analysis will build a regression model. Decision tree will build a tree-based model. So the learning that the machine has looking at data is called the machine learning model. Features are the input properties that you give to the machine, right? So features are the input properties, and dependent variable is the output property, right? So in our case for going out and playing, the weather, the 3 aspects of weather, whether it was sunny, the outlook of the weather, the humidity of the weather, and the wind are the features. And the dependent variable that we are trying to, make the machine learn in that case was the whether to go out and play, right? So features are those things that you give as input. You also give the dependent variables value. What for these features, this was the value, right? And then you want the machine to look at the features, learn from the features so that it can predict the dependent variable value. Next, we also spoke about training and test cycle, right, in the last slide. So whatever data set you give the machine to learn this model is called the training data set. And test data set is the 30% or whatever percent you reserved that you test the machine against. Right? And precision and recall is essentially ways to measure how well the model is performing. Now that we know some terminology, let's use some terminology, how well the machine learning model is performing. Right? So this is some basic ML terminology. Again, this is not comprehensive, but this is just to give you, a sense of what kind of terminology you might have run into already. Right? Right? So now let's take a minute to understand types of machine learning algorithms. We saw 3, machine learning algorithms so far: regression analysis, decision trees, and cluster analysis. But there is a higher level classification of machine learning algorithms. So there are 2 ways in which a machine can learn. It can learn under a human supervision, a human being actually hand picking and giving it data, right? and it can learn without any intervention at all. So you just throw the data at it and say, go learn. So that is the classification. So whenever a human being is involved in helping the machine learn, it is called supervised learning, where we teach the machine with input-output pairs so that it can generate outputs for new inputs, where we as in human beings, right? So that is called supervised learning. So the machine is learning under supervision. So regression analysis, there again, we are telling it take this 70% data and learn from it, right? Decision trees, again, we are giving it the data. We are telling it look at these 3 features and then predict this thing. So such form of machine learning algorithms are called supervised learning, where the machine is learning under a human's supervision. Another types of machine learning algorithms that exist where the machine learns on its own. There's not much supervision required. So the cluster analysis that we saw, right, there we just gave it the data and asked it to split it into 3 buckets. We didn't actually help it any further, and after that the machine itself had that learning that these are the 3 buckets. So those are called unsupervised learning. So the 2 types of machine learning algorithms are either supervised machine learning is supervised learning or unsupervised learning. Okay, supervised is where we help the machine learn, we iterate with the machine to give it inputs and then test the output, see how well excuse me, see how well it's doing, right? So that is supervised learning. And unsupervised learning is where the machine is looking at data and deriving insights and patterns from it on its own without any human supervision. Okay. All right. So we have spent about an hour on theory, and I hope the theory was simple enough to follow, which was the aim of this talk. Now, actually, let's get hands-on. Let's actually build a couple of these machine learning models in Python, which is my preferred language for doing machine learning, and play around. So the 2 hands-on exercises we're going to do is to build a machine learning model which can predict weight of people based on their height, right? So we have a data set where for different people we have their weights and heights, and we're going to build a model which can predict what should be the weight of a person given their height. The next thing we're going to do is build a machine learning model which can shortlist resumes, which can come in, resumes are coming in, it will say yes, shortlisted, no, rejected. And again, it is going to learn from historical data as to how we shortlisted resumes. All right, so without further ado, let's actually go ahead and look at our data sets first. Just to, the data sets, the code repositories, everything that I'm going to use now, going forward in the talk can be found at this URL. This is a GitHub URL where I have put all the, the code and the data that we're going to be using. So there are 2 data sets and there are 2 Python notebooks in which the code will be there. Let me just share this with all of you. So I sent you a chat message with the GitHub repo URL, so you can go ahead and clone this and get access to all of this. Okay, let's first look at our first problem, height weight. So this is the file in that repository that I'm going to first show you. Right? So this is our data set. So we have something called an index column, which is just, like a counter. Then we have the height of the person in inches, and then we have the weight of the person in pounds. So this is our data set. So with this, we want to build a machine learning model which can take the height of the person and predict the weight, right? So now how do we go about doing this? So we're going to do it in Python, and the Python environment that I use is Anaconda. So Anaconda, again, you guys can go to Anaconda and download. Let me just show you. So you can go to anaconda.com and download. So Anaconda is like a Python distribution, right? So it not only comes with Python, it also comes with all the packages, all the bells and whistles that you would normally need for scientific computing, like machine learning, data science, right? So it'll come with all the popular packages, right? So it comes with 1,000+ data science packages, right? It has for Windows, Mac, Linux. You can just download and you can install. So once you install Anaconda, you'll get an Anaconda Navigator app, which essentially is the command that you can run, right? So you can run this command, and once you run it, this is what will open up. And here we are going to use the Jupyter Notebook, which is a way to write Python code in a browser, right? It's a web-based interactive computing environment. So let me first show you what that means, right? So once you click that, it'll start the Jupyter server on your laptop and then open a browser talking to that server, right? So what is this? So we have got essentially our file system loaded here, and let me just show you how to get started with it. So you can create a new notebook using the new, and once you create a notebook, this is how it looks. So here you can start writing Python code, right? And then you can run it. You can write, whatever Python code you want, and you can run it. So beautifully, you can, incrementally write code, run it, and see its output. So it's an interactive web-based, so to speak, IDE in which you can write code. So that's what Jupyter Notebook will give you. Okay. So now let me just close this for now, and let us actually go to our. So I have cloned the repository here in my file system. So I'm just going there, and so the data set we looked at is the height_weight.csv. That is this data set we just looked at. So to solve that, we have the height_weight Python notebook. So let's open that. Okay. So what do we have here? So first thing we need to do is we need to work with the data set that we just saw. So to do that, I have defined the variable in Python with pointing to the data set. And then I'm going to use the pandas package of Python, which is very good to work with tabular data. So this again, I'm not going to go into details of what pandas is, but it is just to give you a sense of what packages can be used to work with tabular data. So pandas is one such package which is very popular to work with tabular data. So I'm importing pandas, and then I am asking pandas to read this file, and I'm telling it to use the tab separator. So once pandas reads this file, the height_weight.csv file, this file, it'll give us back a data frame, and we can look at how the data frame looks using the head method. So let's run this. So this is how it looks. So it's very similar to that file, right? 65 inches, 112 pounds, 65 inches, 112 pounds. So it has created something called a data frame, right? So if you look at our data frame, we have height in inches and weight in pounds. So normally when you do, data analytics, or when you do machine learning, the key challenge you'll face is data won't be in the format that you are interested in. For example, I don't even understand height in inches. I don't understand height in pounds. I'm an Indian, so I work with feet, and I work with kilograms. So that's what I'm doing next. So what I'm saying is, let me create a new column in the data frame called height, where I take the height in inches, this column, and I convert it into feet. So the way to convert that is to multiply inches like this. So I'm doing that, and once I do that, now I have a new column which is the height in feet. So this person is 5.448 feet tall, right? Let's do the same with weight. I don't want to work in pounds, I want to work in kilograms. So I have found out how to convert pounds to kilograms, and that's what I'm doing here. So I'm asking the data frame to create a new column called weight, and the way to create that is to take the weight in pounds and run this function on each of its rows, where I'm converting the pounds into kilograms. So let's run that. Okay. So now we have our height in feet, our weight in kilograms. It's making sense. A guy who's 5.5 feet or a person who's 5.5 feet can be, 51 kilograms. I'm able to relate to data better this way. So now I don't need these old columns. I don't need this height in inches and this weight in pounds. So we can just ask to create a new data frame with just these two columns, the height and weight. I actually don't care about anything else. So I'm taking this data frame and I'm creating a new data frame with just these two columns, the height and weight. That's what I'm doing here. Awesome. So now we have data in a way that we can understand. So first learning, most likely the data you get won't be in the way or in the format that you want. And with pandas, you can easily do this conversion, right? So with what 1, 2, 3, 4 lines of code, we could actually get data to a state in which we can work with. Now, how do we find how many rows are there in a data set? That is the first thing we want to know, right? How much data do I have? So to do that, we need to measure the length of the data frame. This is the data frame that we have created, df, and it has an inherent property called index, which is this column, the 0, 1, 2, 3, 4. It's an automatic column it puts. So if you measure the length of that, you'll get the number of rows. So there are 25,000 records in this database, data set. Okay. So now the next thing you want to know, when you start working with this data is, try to visualize it. How is the height and weight distributed before we actually go ahead and build our model? So before building model, these are the steps normally. You will be cleaning data, then you will be doing some exploratory data analytics. You'll be looking at how the data looks, what is the variations with height and weight. So you'll use some form of visualization. So I want to introduce you to matplotlib, which is another package in Python, which comes pre-installed with Anaconda. So it'll already be there. So if you go to environments and we search for, matplot, it's already installed. If it's not, you can just check this and install it. But it is. That is the beauty of Anaconda. It is a distribution. It comes with all the bells and whistles, all the packages that you would normally need. So I'm using the matplotlib package here, and I'm using the pyplot, right? And what I'm asking it to do is to draw a scatter plot where we throw all the points on a canvas. So to that, I'm saying on the x-axis do the height, right? And on the y-axis do the weight, because we want to predict the weight based on the height. So x-axis is height. So I'm using the data frame's height column. So I'm saying data frame.height, which should give me this column. And on the y-axis, plot the weight, which is data frame.weight, right? And I'm asking it to give some labels, a label to the plot, x-axis label, y-axis label. Let me run this and you'll have a better idea. Okay, so this is how it looks. So all the 25,000 points are plotted here. So x-axis is the height, y-axis is the weight. So this gives you a sense of what it is, right? So given a height, there's a lot of variation in the weight as expected. People of same height does not mean they will have similar weights. It depends on a lot of things, right? Now let us try to build a model to predict the weight of people given their height, right? And what I want to do is to build a linear regression model, which is essentially something like, let me show you, like this. So this is a scatter plot we have done. I want it to learn a straight line, linear regression. So I want it to look at this data and learn a straight line with, and then we'll use that straight line to see how well it has learned. And to build a regression model, a linear regression model, this is the one line of code done. So simple. We are using the SciPy package, which is again a package that will come pre-installed in Anaconda. So that is the beauty of Anaconda. Once you install it, you get all these bells and whistles. It's already right there, right? So, and we are using the stats module from the SciPy package. And all you need to do is say stats dot build a linear regression model where the x-axis is this and the y-axis is this. And what it will give you back, because this is a linear regression, is the slope and the intercept. It will also give you a few more things which we will look at later, but it will give you the slope and the intercept. So that's all you need to define a straight line, right? Y equal to slope times x plus intercept. That is the straight line. So once you do stats.linear regress, you pass it the x-axis, you pass it the y-axis. This is the features, and this is the dependent variable, because you want to predict the height, the weight based on the height. And you do stats.linear regress, it will build that straight line model for you, and it will give you the slope and the intercept, right? So let's actually run this, and let's see how long it takes to calculate this on our 25,000 data set. And it is done. It's already done. So how do we see? Let's actually take this out. Let's say print slope, print intercept. Let's see what is the slope and intercept it has come up with. Okay, so it has come up with a slope of 16.78 and an intercept of minus 37.45. Right? It has given us that straight line. That is the straight line learning or the regressional learning that it has had. Now, how do we see? So let's try to plot that straight line on top of this. Let's see how is it. It should be minus 37 is the intercept, so it should hit somewhere here. So it should be some line like this. Let's see. So to do that, what I'm doing now is I'm defining a function called predict, and it will take a value of x, and it will do mx plus c. So whatever slope I got here is the slope I'm using here. I'm multiplying that with the input that you pass me, and I'm adding. So this is essentially our fx, right? So f of x equal to mx plus c. For m, I'm using the slope that the model gave me, and for intercept or c, I'm using the intercept that it gave me. So this is our function now. This is what the machine has learned, right? So now I'm calling that function on all of our heights, meaning all of our values in x-axis. And this is for each value, it is giving me the output. And now I'm drawing that output as well on top of the scatter plot. So I'm doing the scatter plot like I was doing here. I'm also drawing out this new line, right, in the color red. Now let me run this so that you see. So this is the function that it has learned, right? So now we have this predict function, and this is now we can visualize what is the function that it has learned on top of all this data. We can now call our predict function with any height, right? So let's call it with my height. So I'm 6 feet, let's say. So predict the weight of a person who is 6 feet tall. So it should be basically returning me this value, which should be around 60, whatever. Yeah, 63, right? And then we can predict the height of someone who's 4 feet tall. That's 29, right? So we have now been able to, create a machine learning model, right? Using the stats package in one line of code, which gave us the slope and intercept. And then we were able to use the slope and intercept to create a function. And now we are able to call that function with different inputs to get values. So simple, right? But now we also want to see how good the learning is. Has it learned well or has it learned bad? So for that, it also gives us something called a R value, which is a measure of how much, well the machine has learned. So R squared, once you print, if the value is closer to 1, it is a good learning. If its value is closer to 0, it's not learned very well. And let's run this. So its value is actually 0.25. So it is closer to 0. So it hasn't learned. It's not a very accurate model. As you can see, given a height, there are so many possible weights that are possible. And this guy is just always predicting this. For 5 feet, for 5.4 feet, it's always predicting this value. Whereas real human beings have variation like this. So what is this telling us? Did we choose the wrong model? Or did we do something else wrong? Obviously, our model is very poor. So I am 6 feet tall and I'm no close to 63 kilos. So the model is flawed. But why is it flawed? Is it because we chose linear regression? We should have done some other regression? Or is it because of something else? So the other thing that, in machine learning that you have to do is a machine can't learn if you throw some part of the data to it. You have to think, if I have to build a model which has to predict the weight of the person given, what all are the things that it needs to look at? Height alone is not enough, right? There must be other factors. Maybe gender is a factor, whether it's a male or a female. Maybe, the country matters, because in India, maybe they eat, different kinds of food. Maybe in Iceland, they eat different kind of food. Maybe in Antarctica, people at some height will have. So there are so many other factors which actually go into the weight of a person. Maybe the lifestyle, maybe whether he, is, what kind of occupation does he have? Is he a software engineer, or is he a farmer who actually walks around so much, who does so much physical labor? So essentially what I'm trying to tell you is, you cannot just give the machine some data and expect it to learn and predict well. You have to give it a holistic picture. You have to give it all the attributes which matter. and then give it the weight of the person. And then if it looks at all those attributes, not just the height, all the other attributes that we spoke about, and we build a model, it will be much better, right? It will have a much better learning because it is now looking at all those things and then learning. So the problem with what we did here, though we have learned how to do linear regression, we passed only the height, and we said the weight is primarily dependent on the height, which is not the case. The weight is dependent on a lot of other things. Hence, the machine actually didn't learn very well. But it's okay. Once you give it all those inputs and you can try, maybe it'll have a very good learning. Okay. So in interest of time, let's quickly move on to the second, example we wanted to do, which is to shortlist resumes. So let's look at that data set. So here we did, by the way, in this example, we did regression analysis. We used linear regression. That was one of the algorithms that we learned, regression analysis. And in the next one, I'm going to show you how to do decision trees. And the decision we're going to take is whether to shortlist a resume or not. So now let's look at our data set. Let's do this a little quickly in the interest of time. Yes. So this is our data set. This is handcrafted. This is something I wrote, myself. So it's not a big data set. It's not a real data set, but we can, learn, see how to do how to do decision trees using it. So this is a data set which says there was a candidate with 95% grade with 0 years of work experience, which we shortlisted historically. There is another person with 85% grade and zero work experience, which we did not shortlist. So this company is some elitist company. It's not shortlisting people, with 85% grade. But if he has 90% grade and 1 year of experience, yes, we shortlisted. If he has 60% grade but 1 year of experience, we did not shortlist. That is what this data is telling, right? This guy has 60% grade but has 15 years of work experience, still we did not shortlist, right? So let's see, when we throw this data at the machine and ask it to learn and create a decision tree, what kind of decision tree does it come up with? So to do that, we will now go to our second thing, which is resume shortlist.ipython notebook. Let's open that. So here again, we are essentially, reading the file, the same file, this file, into a data frame, and we're looking at it. So let me quickly run through this. So this is the data, 95% grade, 0 work ex, whether we shortlisted or not. So these are the two features which we will give to the model, and this is the dependent variable or the thing it has to predict. We'll give these to the model and ask it to learn, right? So as I said, here the data is represented as a yes, no, but what we require to pass is numbers. So what I'm doing here is I am replacing this column with another column with the same name, where I'm replacing yes with 1 and no with 0. When I run this, my data set becomes like this. So yeses have been replaced with 1s and no's have become 0s. So now, what are the features that I want to pass? I want to pass the grade and the work experience. So I've created a Python list with those two features. And what I want, is the shortlisted field. So I've picked out the shortlisted field and given it the value of y, and x is these two columns from the data frame, the grade and the work experience. So that is my x-axis, this is my y-axis, and I'm going to build a decision tree. Again, as simple as we imported, sklearn here and the tree module from it, and we can just say tree.decision tree classifier, and we say fit. This is the x features, this is the dependent variable y, build the tree. Done, it has built it. As simple as this. Again, one line. Now let's try to use that to predict. A guy who has got 9, what is the first thing we have to pass to it? We have to pass the grade. One who has 99% grade and has 2 years work experience. So what's our guess? 1. 1 means yes, meaning we will shortlist. Now let's take a person who has 20% grade and 15 years of work ex, but he had only 20% grade. So when we run this, expected is 0. We won't shortlist it. Now this is some magic Python code to actually ask the to actually draw out the decision tree that it has learned. So once I run this is the decision tree it has learned. And I want to just spend a minute explaining how to go through this. So it's saying this is the tree. You first look at grade. If the grade is less than 65%, right? If the grade is less than equal to 65%, that is true, then this is the values for 0 and this is the values for 1. Right? So it is saying there are 3 data points that have less than 65% and you have not shortlisted, you have rejected all the 3 and you have shortlisted 0. So the grade is less than 65%, simple, go ahead and reject. But if the grade is greater than 65%, then work experience comes into picture. If he has less than 0.5 work experience, right, then again grade comes into picture. If he has less than 90%, you do not shortlist. There's only 1% and you did not shortlist. But if he is less than 0.5 years of experience and grade is greater than 90, you go here. There is one data point that I found and you actually shortlisted him. So you would shortlist a person if he, you will directly reject if he has less than 65%. But if he has more than 65%, work X comes into picture. If he has greater than 0.5, then you shortlisted all of them. But if he has less than 0.5, then again grade comes into picture. If it's less than 90, you go ahead and reject them. If it's greater than 90, you actually go ahead and shortlist them. Right? So this is so awesome. The machine, just looking at data, has come up with this. Right? Looking at this data, it would have been hard for us to even come up with this. For a human being to come up with this, it would have been difficult. But just showing the machine this data, asking it to build a decision tree, it has come up with a decision tree, which we are able to call with different inputs of experience and grade and experience and see what it predicts. All of that in this much code. So simple. Okay. So those are all the things that I wanted to cover. Now, maybe I can spend the next 10 minutes answering questions. Yeah. So one of the questions that has been posted by Yoganand, is what is the difference between machine learning and AI? Right? Is it necessary to learn machine learning in order to learn AI? So this is a great question. It's often a source of confusion. So artificial intelligence is the overall stream of computer science where the aim is to make machines act intelligently. Right? So that is the overall broad category. In that, there are 2 main fields. One is machine learning itself, where the machine is learning from data to build these kind of models, right? And the other type of AI is essentially deep learning or neural network based learning, where the study is primarily around how neural networks, which is a mimic attempt at mimicking how our brain works, can be used to train the machine, right? So machine learning is actually a subset of artificial intelligence. Artificial intelligence is the broad field. In that, lot of risk. So this is not an old field also. This has been around since 1980s or maybe even before that, maybe even 1940s, maybe all the way back, right? So the aim there is to make the machines act intelligently. So artificial intelligence is a broad umbrella. Machine learning is one way in which AI can be achieved. The other way in which AI can be achieved is deep learning, neural networks, right? Which is a study in which trying to mimic how our brain works. Neurons, connected neurons firing, right? Millions and millions of neurons. That's what our brain is. So basically, machine learning is a type or is a way in which you can achieve artificial intelligence. There are other ways, other attempts, other studies going on how to make you make the machines act intelligently, where there is deep learning, neural networks, and all of that, right? So that is the difference. So they're not parallel entities. Machine learning is a way to achieve AI, right? And is it necessary to learn machine learning in order to learn AI? No. If you're learning machine learning, you're already learning a subset of AI, right? But there's this other subset of deep learning and artificial neural networks and all of that. Yeah. In the other thing, the other question that has been asked by Srinivasan is in the decision tree flowchart, how to decide that Outlook should be the first node? Why not rain? It could be rain as well. My point is, we did not decide that. That is the learning the machine had. We just gave the machine the features, asked it to build the, the model. And the model that it came up with is what I have shown there. So it has itself first picked Outlook. So based on the data, it knows if Outlook is the key factor that plays. First, I should look at Outlook. What it does to do that is to reduce entropy. So that is a detailed subject. How it decides which parameter to first look at is in logic inside itself. It knows how to pick, right? So what I have shown there is not the model that I have given the machine. That is the model that the machine has given back to me, right? So I'm talking about this step. So this step, the machine has actually picked up that we should look at Outlook first. I did not tell it to look at Outlook first, right? And in our case, in the end, if you see here as well, resume shortlist, it is the machine that has picked up grade. We did not ask it to pick grade first. We just gave it two attributes, grade and work experience. And it has chosen what to look at first, then what to look at next, then what to look at next, and then decide. Okay. All right, guys. That's all I have from my side. In the interest of time, I'm going to close this session now. I hope it was useful to all of you, and and I hope you guys continue your learning with great learning with our PGP-ML and our AI-ML programs. And just to tell you guys, I've already taken your first steps, showing interest, showing up here on a Sunday, right? Having the interest to learn. That is the first step. And I think you have taken that. Today we have taken the second step where we have learned a little more about machine learning. And I would encourage all of you to keep learning. Thank you for your time, and it was great to have you here. Bye.